Hi guys, today we are going to look at the final type of chemical reaction that we will examine in this unit, and it is combustion. So combustion is a chemical reaction in which fuel burns in oxygen to produce combustion products: carbon dioxide, water, carbon monoxide, and carbon, and a flame. Combustion reactions also release chemical energy such as thermal energy or heat and light. The majority of fuels used today are composed of a special group of organic compounds known as hydrocarbons. And a hydrocarbon, as the name suggests, are molecules made up of only two elements, hydrogen and carbon. They contain one or more carbon-carbon bonds and one or more carbon-hydrogen bonds. A couple of examples are propane, C3H8, and butane, C4H10. Hydrocarbons are extracted from fossil fuels, such as coal, oil, and natural gas, from the earth. They are burned for their energy content, and the energy obtained through hydrocarbon combustion is primarily used for transportation and the generation of electricity. So two types we will look at are complete and incomplete combustion. In complete combustion, there has to be enough oxygen in order to produce carbon dioxide, water, and energy as the products. And the general unbalanced chemical equation for the complete combustion of a hydrocarbon CXHY is CXHY plus O2 produces carbon dioxide and water and energy. There must be sufficient oxygen for this to happen, and this will be indicated on top of the arrow generally, but it could also be shown beside oxygen or beside the reaction, but it must be indicated so that the reaction will proceed as complete combustion. And complete combustion usually occurs when there is an excess, which means there's more than enough oxygen present. You see complete combustion when we light our Bunsen burners. Generally, it is a bright blue flame, and if it's not bright blue, that indicates that there's incomplete combustion, therefore not enough oxygen. So we change the amount of oxygen in the reaction to make the flame be bright blue, and that will give us the hottest and cleanest flame. An example would be methane gas, the one that we use in our chemistry lab, and the one that you burn in your homes. And methane is CH4 plus 2O2 produces carbon dioxide and water and energy. Again, sufficient oxygen must be indicated when you indicate this type of reaction. And the other type of combustion, incomplete combustion, this happens when the supply of oxygen is limited. And the products here could be carbon dioxide, carbon monoxide, soot, which we represent it as carbon as a solid in an equation, water, and energy. The lack of oxygen prevents complete combustion from occurring, and we end up with a sooty, cooler flame, and that would be our yellow flame. Because there are so many products possible, we cannot always indicate incomplete combustion by a single chemical equation. So for example, the incomplete combustion of heptane, C7H16 as a liquid plus 7O2 as a gas, to produce 3 carbon as a solid, 2 carbon monoxide as a gas, plus 2 carbon dioxide as a gas, plus 8 molecules of water as a gas, plus energy. A second reaction could also be taking place, where we'd have 2 molecules of heptane plus 11 molecules of oxygen produces 14 molecules of carbon monoxide plus 8 molecules of water as a gas plus energy. For our purposes, we will focus on the first type of reaction, the first reaction indicated. So focus on this one because for our purposes it's easier just to know one. By comparison, there is only one chemical equation for the complete combustion of heptanes. So if we have heptane, we would have 11 molecules of oxygen produces 7 molecules of carbon dioxide and 8 molecules of water plus energy. Again, sufficient oxygen must be indicated. For this to take place. So when you need to indicate that a reaction is complete combustion, you simply need to put carbon dioxide and water as your products and balance if it indicates that you must balance that one. So this is the end of our types of reactions. So let's take a look at the summary of all the types we've looked at so far. So we have synthesis, and a clue that we have a synthesis reaction is that we have an element plus an element generally indicates that we have a synthesis reaction as a reactant. If we have a single displacement reaction, we have an element plus a compound as the reactants. For a decomposition reaction, we have the reverse. We would have a compound as our reactant. And for double displacement, we would have two compounds as our reactants. And if it was our special type of double displacement, which we will look at in our next lesson, again, we have a neutralization we need to have an acid plus a base as our reactants. And lastly, if we have complete combustion, we need to show, well, there has to be sufficient oxygen present, and our products will always be carbon dioxide and water. And if it's incomplete, of course, we have insufficient oxygen, and our products that we will show are carbon dioxide, carbon monoxide, carbon, and water. So that summarizes the types of reactions that we have looked at overall. There are a few exceptions in the various types, but hopefully this helps you to further understand the different types of reactions. You'll now need to look at your content on the LMS for the homework that you must do for this section. Please send any questions you may have by email to your instructor.